Hello. In this video, we will try to understand the concept of runtime polymorphism in C++. Now, polymorphism is one of the properties of object-oriented programming. And under polymorphism, we have two types, runtime polymorphism and compile time polymorphism. Compile time polymorphism involves operator overloading and function overloading. So in this video, we will focus on runtime polymorphism. For the compile time polymorphism concepts, we will understand them in the upcoming videos. So in order to understand the concept of runtime polymorphism, I have written this code over here. So let me explain you what this code is all about. So in the beginning, I have included the IOStream header file, and I have created two classes, a base class and a derived class. And the derived class, as you notice, is inheriting the base class. Now, if you're not familiar with this inheritance behavior, so inheritance again is one of the properties of object-oriented programming, wherein it is possible to inherit the members of the base class into the derived class. So the derived class here is inheriting the base class, and the base class consists of two functions, function 1 and function 2. And if you notice, I have marked function 1 as virtual, and in the derived class, I have used the override keyword for the function 1, where I am defining the function 1 and function 2 once again. So to explain the significance of this here and the override keyword, so this is the way for us to override the function of the base class in the derived class. Now, even if I do not use the override keyword, and I have marked that the function 1 as virtual, it's still going to work fine in terms of a compilation or in terms of the output. But the override keyword is one of the best practices wherein we inform the compiler that we think we are overriding the function 1, and if we are actually not, then please inform us. For example, I have not marked the function 2 as virtual, and now if I think that I am overriding the function 2, then I can mark it as override, and immediately you can notice that there is an error, and if you hover, it says member function declared with override does not override a base class member. So this is one of the best practices, that whenever we think that we are overriding a function, we can mark it as override. So we have two functions here, function 1 and function 2, one marked as virtual, and I have marked it as override in the derived class, and the other function is the function 2, which I have not marked it for overriding. So further, in the main function, I have created an object of the type base class, which is pointing to the derived class. And using such an object, I am invoking function 1 and function 2. And in each of the function, I have put a basic print statement, which helps us in understanding which function is invoked and at what point in time. So this is the code that I have written, and I would suggest you to pause this video for a while and think and analyze what shall happen when the line number 46 and 47 is invoked in the code. So just try to understand, and once you're done with your analysis, we'll go ahead and now check what is going to be the output. So first I will have to compile this code, and once the compilation is done, I will run. So now if you notice the output, for the function 1, when I invoked it using the object, the derived class function 1 is invoked, but for the function 2, the base class function is invoked. So now this is the difference of using the virtual keyword and overriding it, and the whole concept of runtime polymorphism, because when we use the virtual keyword and override it in the derived class, and we have an object of the type base class which is pointing to the derived class, and we invoke such a function, the derived class function will be invoked because late binding takes place in such a case. So in the case of late binding, it's not the type of the object, but it is the content of the object, or what that object is pointing to. That factor is considered at the runtime in order to determine which function has to be invoked. Whereas in the case of function 2, the early binding takes place, and that's why in the case of early binding, the type of the object comes into picture. And since the object is of the type base class, for the function 2, the base class function is invoked. But since the object is pointing to the derived class, in the case of function 1, the derived class function is invoked, because in the case of function 1, the late binding is taking place. So this is the concept of runtime polymorphism in C++, wherein you mark the function as virtual and then override it in the derived class. Now, I have to inform that there is another essential a thing to be taken care at the base class in terms of the destructor, but I will reserve that concept for the next video. So I hope this concept of runtime polymorphism is clear to you, and I hope this helps. And please share your thoughts in the comment section. It always helps me. Thank you.